Just a quick little carding about numbers 9 and 6 from homework 8. So here's number 9. This is clearly a trig substitution problem. It's got a number squared minus something x squared involving x. So the first thing I would do is change this to square root of 5 squared minus 9x squared. Just so we can see what the a and the so forth are. Then we do that, it reminds me of the derivative of arc sine, except there's not a 1 there. So if we factor out the 5 squared, we get 1/5 on the outside, the square root of 1 minus, and then here we're going to have a 9x over 5 squared dx. And again, the derivative for arc sine is 1 over the square root of 1 minus, we could say u squared du. So that looks very similar to that. So that means that if we integrate that, we're going to get arc sine of 9x over 5. But then we have to ask ourselves, does that, if I take the derivative of that, it's going to kick out a 9/5. And we already have a 5th out there, so we don't need that. So then we have to put a 9 out here, so we can get 9/5. And then, of course, a plus c. Oops, I went the wrong way. It's going to kick out a 9, and we don't want a 9, so we need a 1/9 up there. So when we kick out the 9/5, the 9s will cancel, and it'll leave a 1/5, and that's exactly what we want. So that's number 9. Number 6 also reminds me of arctan. So we know the derivative of arctan is 1 over x squared plus 1. So we need to factor out that 49. So I'd put it 1/49 out here. And of course, when I factor that out, that leaves an x over 7 squared plus 1. That looks just like that, except for it's an x over 7, so an x squared. And we also need to change, because it's an improper integral, we'll change that to an a. We'll put the limit as a approaches infinity over here. So then when we integrate this, we get arc tan of x over 7. Of course, the derivative, we'll take the derivative of that, change was going to kick out a 1/7. I want a 1/49. So we need an extra 1/7 there. And whoops, I didn't leave room for the limit. We still have the limit as a approaches infinity. I'm evaluating this from 1 to a. So now do 1/7. I keep forgetting to write the limit. Limit as a approaches infinity of 1/7 arc tan of a over 7 minus 1/7 arc tan of 1 over 7. So then when we let a approach infinity, if you remember what arctan looks like, it looks something like this. there's asymptotes above and below. The asymptotes are at pi over 2 and negative pi over 2. So as a gets bigger and bigger and bigger, that means we're going way out to the right, and arctan is getting closer and closer to pi over 2. So this thing becomes 1/7 times pi over 2. And that thing is just 1/7 arctan 1/7. Because as a approaches infinity, that's not doing anything, it's just staying put. So our final answer here is pi over 14 minus 1/7 arctan 1/7. Alright,